Hello, my dear students. Good morning. Today, we are going to discuss average acceleration and instantaneous acceleration. So, he is my student, Mr. Revant. Okay.
Sir is Prasanna Kumar.
Okay. So, I am Prasanna Kumara, physics teacher. So, welcome to physics class, my dear students. See, in the last class, we discussed about position vector, displacement vector, average velocity vector, and instantaneous velocity vector. So, if you do not remember those concepts, again rewatch that last video and be thorough with the concept. Okay. What is average acceleration?
The ratio of change of velocity with respect to the corresponding of time interval.
Okay. So, ಹೇಗೆ ಹೇಳಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ that is average acceleration is defined as it's a ratio of change in velocity to the corresponding time interval. ಹೌದಲ್ಲೇನಪ್ಪ?
Yes, sir.
Right. So let us write that mathematically. Average acceleration vector, because acceleration is a vector quantity, it has both magnitude and direction. Okay. So average acceleration is equal to, it's a ratio of
Change in
velocity to the corresponding time interval. So I need to write here vector quantity.
Yes, sir.
Okay. So average acceleration is equal to, it's a ratio of change in velocity
with
to the
respect to
corresponding time
time interval.
interval. Then I can also write this v, because v is a vector quantity here. So it's changing both in x-axis and,
And
y-axis. Correct. So then I can write here that
Delta.
is delta
Vxi cap
v suffix x
xi cap
into I cap plus
v
v
suffix
suffix
y
y
into j cap.
into j cap, right?
Hmm.
So divided by delta t.
T.
Correct?
Hmm.
Okay. Right. So then this can also written as, that is
Delta.
average acceleration is equal to delta v suffix x into I cap divided by delta t plus delta v suffix y divided by delta t
J cap.
into j
J
cap
cap.
ಅಂತ ಬರಿಬಹುದು. ಹೌದಲ್ವಾ?
Yes, sir.
So now what is this change in velocity with respect to time? Acceleration, right? So that I can write here the total average acceleration is equal to a suffix x, average acceleration along x axis, okay, right, into I cap plus a suffix y
into j
cap. Correct?
Yes, sir.
So the average acceleration is equal to a suffix x into I cap plus a suffix y into j cap. Correct? Right. So what is the magnitude of this average acceleration?
Root of x square plus ay square.
Very good. So the average magnitude of average acceleration vector is equal to root of a x bar whole square plus a suffix y bar whole square. So this will give the magnitude.
Yes, sir.
So then if I want to find the direction,
Yes, sir.
what to do?
Root of I square plus j.
No, that is theta
no, sir, tan
is
theta.
equal to tan inverse of, correct?
Yes, sir. Yes, sir. Yes.
A suffix y bar divided by
A suffix x bar.
x bar. That is theta is the angle between the resultant vector with respect to x-axis. ಹೌದಲ್ವಾ? The
Yes, sir.
component which is along the x-axis. Then theta is equal to tan inverse of
A suffix
y bar
bar
divided by
A suffix x bar.
A bar.
Yes, sir.
Correct? Okay. Right. Then we'll define what is instantaneous acceleration.
Yes, sir.
Right? Okay. Now let us define instantaneous acceleration. How did we define instantaneous velocity? Do you remember?
Yes, sir.
That
Limiting.
Yeah, correct. So the limiting value of average velocity as time approaches to zero
tends
is
to
called instantaneous velocity. Okay, similarly, we'll define instantaneous acceleration. That is, instantaneous acceleration is defined as the limiting value of average acceleration.
Okay, sir.
We are defining instantaneous acceleration now. Instantaneous acceleration is defined as
The limiting value of average acceleration
as the time approaches to zero
or tends to zero.
Or tends to zero. So is called instantaneous acceleration.
Yes, sir.
Right. Okay. So then instantaneous acceleration we will denote it as a vector.
Yes, sir.
Correct. So a vector is equal to
Limit
the limit of
a
right,
tends
average acceleration, that is a bar vector. Correct.
Yes, sir.
So tends to delta t approaches to zero on the bari.
Yes, sir.
Okay. So now let us write that what is a bar vector. That is the limiting value of average acceleration. That is delta v vector divided by delta t when delta t approaches to zero. Right.
Yes, sir.
So that is limit of change in velocity with respect to time, then delta t approaches to zero. Right. So the limiting value of average velocity, average acceleration. So the limiting value of average acceleration as time approaches to zero is called instantaneous acceleration. Then I can also written as that is dv
by dt
divided by dt and the both. Avdalva, right? So that is dv divided by dt. Correct?
Yes, sir.
Okay. So this will give instantaneous acceleration. Then if I do the substitution here, that is instantaneous acceleration is equal to, right? So then d divided by dt, v can be written as its component along x-axis and y-axis. What is the component along x-axis and y-axis? Correct. That is v suffix x into I cap plus v suffix y into j cap. Correct?
Yes, sir.
So then that is instantaneous acceleration is equal to d by dt of v suffix x into I cap plus
d by dt of v suffix y into j cap.
Correct. Into j cap. Right? So then a vector is equal to what is d suffix vx divided by dt, that is component of the acceleration, instantaneous acceleration along x-axis. That is a suffix x into I cap plus a suffix y into j cap. So this is instantaneous acceleration. Correct?
Yes, sir.
Okay. So what is the magnitude of instantaneous acceleration now? That is magnitude of a vector is equal to root of a suffix x square plus a suffix y square. Correct?
Yes, sir.
Okay. So then if you want to find the direction, then theta is equal to tan inverse of a suffix y divided by a suffix x.
Yes, sir.
Okay. So till now we have defined the position vector, displacement vector, acceleration, average velocity vector, instantaneous velocity vector, average acceleration vector, and instantaneous acceleration vector. Correct?
Yes, sir.
Okay. So let us work out one problem based on this concept.
Okay, sir.
Okay. Right. See, here I have one problem, right? That is the position vector of the particle is given by r vector is equal to 3.0 t I cap minus 2.0 t square into j cap plus 4.0 k cap, where t in second and r in meter. Then what we need to find? Find velocity of the particle. And sub question B is acceleration and sub question C is magnitude of velocity at time t is equal to 2 seconds. Correct?
Yes, sir.
Okay. So let us write the solution for this problem.
Yes, sir.
Right. Solution. Sub question A, right?
Yes,
to find the velocity of the particle. So write r vector, what is given? That is position vector.
Yes, sir.
R vector is equal to 3.0 into t I cap minus 2.0 t square into j cap plus 4.0
K cap.
into k cap. This is what the given position vector, right? So what we need to find?
Velocity of the
vector.
particle.
Correct, velocity of the particle. What is velocity of the particle or velocity? How to define the velocity? Rate of displacement.
Per
ಹೌದಲ್ವಾ?
time.
ಹೌದಲ್ವಾ? No, rate of displacement ಅಷ್ಟೇ,
Okay, sir.
right? So the position of the particle is changing with respect to time
Time
t.
t.
It will give velocity of
Velocity
the particle. Then I can write here, that is velocity vector v vector is equal to dr vector divided by dt.
Yes,
Correct? Now let us substitute that r vector.
Three-
So d by dt of 3.0 into t I cap minus 2.0 t square into j cap plus 4.0 into k cap. Correct?
Yes, sir.
Okay. Vector v is equal to d divided by dt. What is r vector? That is 3.0 into t I cap
minus
minus
2.0
into t
T
square
square j
into
cap
j cap
plus
plus
4.0 into k cap.
4.0 into k
K
cap.
cap.
See, we need to recall one mathematical formula here.
Yes.
ಓಕೆ, ಸೊ ಒಂದು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಫಾರ್ಮುಲಾ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಇವಾಗ ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ, ವಿ ಆರ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟಿಂಗ್ ದ ಆರ್ ವೆಕ್ಟರ್. ಆರ್ ಇಸ್ ವಾಟ್? Position vector. R vector is a position vector with respect to time. So the formula is that is differentiation of x to the power of n with respect to x is equal to n into x to the power of n minus 1. Okay, right? So differentiation of x to the power of n with respect to x is equal to n into x to the power of n minus 1. So by using this formula, we'll differentiate. So here what we are differentiating, that is differentiation of t to the power of n with respect to t.
Yes, sir.
Okay, right. So then v vector is equal to differentiation of 3 is a constant. Take out, right? So write it outside. Differentiation of t with respect to t, how much? 1. Right?
Yes,
so into j cap. Correct? Okay. So minus differentiation of 2 is a constant. Write it as it is.
Yes, sir.
Correct? Differentiation of t square with respect to t.
Yes,
so
sir.
how much it is? 2t. Correct?
Yes, sir.
Okay, let us write that
4t.
into 2t into j cap.
Yes, sir.
Right? So plus differentiation of that is 4 constant. Keep it as it is.
Yes, sir.
Different, nothing, no function is there here. No
Yes, sir.
variable term is there.
Yes,
Right?
sir.
If there is no variable term, the differentiation of 1 with respect to t, it's a 0.
Constant. 0.
Right? So it is 0.
Yes, sir.
Okay, so 0 into k cap.
Yes, sir.
So now what we get? Velocity vector is equal to 3j cap minus 2 into 2, 4t j cap. So that is 3
Sir,
I cap, 3 I cap minus 4t j cap. This is velocity vector, that is meter per second.
Yes, sir.
Correct? So we found the velocity vector. So what is our sub question B? That is to find the acceleration, right? So acceleration vector is equal to dv divided by dt. Correct?
Yes,
okay, so then what is velocity vector? We got that is differentiation of velocity vector with respect to t vector. Just to do the substitution here, 3 I cap minus 4t
j cap.
Correct?
Yes, sir.
So now differentiate by using the same formula, that is differentiation of x to the power of n with respect to x is n into x to the power of n minus 1. Use the same formula. Yes, and do the substitution here, right? So then vector a is equal to differentiation of 1 with respect to t, it's a 0.
Yes,
right? So 3 into 0 minus 4 is a constant.
Yes,
differentiation of t with respect to t is 1. Then 1 into j cap. So then 3 into 0 is how much? 0. Then vector a is equal to minus 4 j cap. So we got the solution for acceleration. That is acceleration is equal to minus 4 j cap meter per second
Square.
square.
Yes, sir.
Understood?
Yes, sir. Yes.
Okay. Next, what we need to find? We need to find
Magnitude of
magnitude of the velocity
velocity.
vector when time t is equal to 2 seconds.
seconds.
ಹೌದಲ್ವಾ?
Yes, sir.
Right? So, subquestion C, let us solve that one.
Yes, sir.
That is to find the velocity, magnitude of velocity vector
Yes, sir.
when time t is equal to 2 seconds.
Yes,
Right?
sir.
Fine. So, now first we'll substitute the time t is equal to 2 seconds. So, then we'll find the magnitude.
Yes, sir.
That is
3 I cap.
right. So let us write that one. Vector V is equal to 3 I cap minus 4. What is the time?
8.
2.
2. Yes, sir.
Right? 2 into j,
J
cap.
cap.
So then what we will get? That is 3 I cap minus
8.
4 into 2. That is minus 8 j,
J
cap.
cap.
Okay. So then magnitude of velocity vector is equal to, what is the formula? Root of Vx square plus V suffix y square. Correct?
Yes, sir.
So this is equal to, so V suffix x is how much? 3.
3.
Right?
3 square.
So root of 3 square plus minus 8 whole square.
Yes,
correct? So root of 3 square plus minus 8 whole square.
Yes, sir.
So the magnitude of V vector is equal to, that is root of 3 square is how much?
9.
So 8 square is, whole square is there, minus square is 64. Right? So 64 plus 9. 73.
73. Yes, sir.
73. Right? So root 73 is the magnitude of V vector. So you can write here
meter per second.
So if you want, you can simplify further. That is V is equal to root 73. Take a root of 73, then you can write the answer.
Yes, sir.
But it's enough to just, even if you write this answer also, you will get the marks in the exam. Okay, right. So then if I ask, the question is not there in the problem, given problem. If I ask to find out what is the direction of this velocity vector ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ?
40 ಅಂದ್ರೆ this divided by 3i.
Yeah, that is theta is equal to
tan inverse of
minus 8 divided by 3.
Yes, sir.
Okay, so then you will get the direction. Correct, alva?
Yes, sir.
So this is magnitude and this is direction. Understood?
Yes, sir. Yes, sir.
Okay, see, from this problem what you understood is the position vector is given, that is 3 I cap minus 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಪೊಸಿಷನ್ ಇದೆ. ವಾಟ್ ಈಸ್ ದ ವೆಲಾಸಿಟಿ? along the z axis there is no velocity of the particle.
Yes, sir.
Sir, how do you say anta ಹೇಳಿದ್ರೆ, see here the velocity is equal to 3 I cap minus 40 j cap. So what is the velocity of the particle along z axis? It's 0.
Yes, sir.
Correct? Okay. And the velocity of the particle along x axis is how much? That is 3 I cap. ಹೌದಲ್ವಾ? Along y axis is minus 40 j cap. Means the velocity is changing along only y axis and the velocity is not changing along x axis. Then what is the acceleration of the particle along x axis? It's 0. What is the acceleration of the particle along z axis? It is 0. What is the acceleration of the particle along y axis? That is minus 4 meter per second square.
Yes, sir.
ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಈ ಕೊಟ್ಟಿರುವ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಫಿಸಿಕ್ಸ್ ನ ಏನು ಅಂತ ಕೂಡ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಜಸ್ಟ್ ಡಿರೈವೇಟಿವ್ ಮಾಡಿ, ಸೊ ವಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟೆಡ್ ದ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್, ವಿ ಗಾಟ್ ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್, and we differentiated velocity vector with respect to time and we got the acceleration. But you should also know the meaning behind that problem. Okay, na? Right? Artha aitalva?
Yes, sir.
Fine. Okay, so my dear students, I believe that you understood this position vector, velocity vector, position vector, displacement vector, average velocity vector, instantaneous velocity vector, average acceleration vector, and instantaneous acceleration vector. And also we worked one problem. So you need to take more problems and work out based on this concept and be thorough with the concept. So I hope all of you understood this concept. See you again in another class. Have a nice day. Bye bye.